Hey guys, welcome back to my YouTube channel. Today I'm going to be showing you how to basically simplify an expression that looks something like this involving factorials. So with factorials, let's say we have 4 factorial right here. Let's say we look at that. 4 factorial. 4 factorial is the same as 4 times 3 times 2 times 1. So as you can see here, with factorials, it's the number, right? And then multiply by the number less than it by 1, right? Subtract 1 from 4, you get 3. Now 3 subtract 1, you get 2. And 2 subtract 1, you get 1. So all the way down to 1. 4, 3, 2, 1. Like a countdown. So here with 29 factorial, it's 29, 28, 27 times 26. Times 25, times 24, times 23, times 22, times 21, times 20, and so on and so forth, all the way down to 1 like a countdown. Okay, that's 29 factorial, and same with 27 factorial, starting from 27. So to simplify this, right, we want to get rid of the factorials. So what we can do here, 29 factorial, right, we can actually rewrite this. We can rewrite 29 factorial, right? 29 factorial, we can rewrite it as 29 times 28, right? Countdown. And then it will be 20 times 27, times 26, times 25, times 24, and so on and so forth. But we can make it a little bit more simpler instead. We can multiply by 29, multiply by 28, multiply by 27. And then from here, we can add a factorial like this. And that is because it counts down from 27 all the way down to 1. 29 counts down to 1. 27 also counts down to 1, right? So it's like 29, 28, 27, and then 26. This factorial already shows us that we count down. So here it starts at 29, that's why we write the 29. It's just 27 factorial. The only difference is you multiply by the 28 and the 29 to this 27 factorial. So here we have 27 factorial in the denominator as well. We actually made the decision to put in 27 factorial right here, not randomly, but from what we see here in the denominator, because here we have 27 factorial. Because we know that if we do this, we can cancel this with 27 factorial, right? So I'm just going to copy the denominator right now. Everything from the denominator copied right here. So we just have to cancel this and this, because we're dividing both the top and bottom by 27 factorial and 27 factorial, and that's why we get rid of these, okay? And so that's why 27 factorial will be gone. So here we will be left with 29 times 28 all over 4 factorial. So 4 factorial, okay? And then here we can see that we have 28, and we know 28 is divisible by 4, but we need to take this factorial apart in order to get access to the 4, right? Because remember here, 4 factorials equals 4 times 3 times 2 times 1. We can have access to the 4 to cancel it, right? And simplify. So let's do that. So 29 times 28. And let's break this apart. 4, 3, 2, 1. Good. Countdown. Now we can do 28 divided by 4 and 4 divided by 4. 28 divided by 4 is going to give us 7. 4 divided by 4 is going to be 1, so like 4 cancels. And so here's what we will be left with. We will be left with 29 times 7 over 3 times 2 times 1. 3 times 2 times 1. And now here everything is factored out. And we can see here, right, this is factored out, this is factored out, and we can't cancel anything. We can't really divide anything from the top and bottom, right, to simplify it further. So let's just multiply them together. So 29 times 7, so 29 times 7 is going to give us 203. 3 times 2 times 1 is going to give us 6. And there we have it. We have simplified this expression right here. So say we have an expression that looks something like this with a variable inside, right, and the factorials. Let's see. N plus 3 factorial. What can we express this as? Well, we know that for any number and there's a factorial sign, it's like a countdown. So for n plus 3 factorial, for instance, it's going to count down, right? So it's going to go from n plus 3, okay, and then the number less than it. What's less than n plus 3? Like 1 less than n plus 3. Well, it would just be n plus 3, and then we have to subtract 1 from it. And that would just be n plus 2. So this next number is going to be n plus 2 because it's 1 less than n plus 3, right? So we multiply by the one that's 1 less. And what's 1 less than n plus 2? Well, we can do n plus 2 minus 1. That's going to be n plus 1. Okay, so we subtract 1 from the next one. So each time it decreases by 1, right? So it's going to be n plus 1. And then what's 1 less than n plus 1? Well, if you do n plus 1 minus 1, you're going to get n. So this is going to be multiplied by n. And then what's less than 1 less than n? Well, 1 less than n is going to be n minus 1. So we're going to multiply this n, right, by n minus 1. And now what's 1 less than n minus 1? Well, if we take n minus 1 and we subtract another 1, we're going to get n minus 2. So this is going to be n minus 2. And it keeps going on and on and on, right? All the way to multiplying by 3, 2, 1, like a countdown. Just like that. So how does this apply in this case for this question? Well, we can recognize that n plus 3 factorial, right, will encompass n minus 2 at some point, right? Because this n minus 2 is also a factorial, we want to get rid of n minus 2 factorial. We can strategically recognize that it counts down from n plus 3, so n plus 3, right, is the starting one. And then the next one is n plus 2, because 1 less than n plus 3, as mentioned before, is n plus 2. And then 1 less from that is n plus 1. And then 1 less from that is n. And then 1 less from that is n minus 1, and then the next one, 1 less from that is n minus 2, and it goes all the way down to 1, right? It's like a countdown, as shown right here. It counts down all the way down to 1 from n plus 3, and at some point it reaches n minus 2. So it's a countdown, right? We have to recognize it's a countdown from n minus 2. It'll keep counting down, so it's a factorial, right? It's going to keep counting down to 1, so we have to add this factorial symbol. This work was on the side, so I'm just going to draw a line here just to avoid confusion. So now we recognize we have n minus 2 factorial, and I chose specifically to stop at n minus 2 factorial, like listing out the terms, just so we can cancel this out, right? It's strategic, okay, the strategic move. It's not arbitrary, so we can cancel this and this out. And now that we have canceled it out, we can recognize that this expression is going to be equal to n plus 3 times n plus 2 times n plus 1 times n minus 1. And you can even make it look nicer, bring this n in the front. And you can maybe even expand it if you'd like. So yeah, we have the expression for this, okay? So recognizing that the trick is to cancel out the factorials by expanding one of them all the way to a certain number. Alright, so say now we have to solve for n, and we have some factorials here. Now, the trick to do this is to simplify the factorials just like before. We know that n plus 4 factorial is the same as n plus 4, right? Times n plus 3, because n plus 3 is 1 less than n plus 4, because if you do n plus 4 and you subtract 1, you're going to get n plus 3. And if you subtract 1 from n plus 3, so n plus 3 minus 1, you're going to get n plus 2. So n plus 2, and then n plus 1, and so on and so forth, okay? So this is n plus 4 factorial, and it goes all the way down to 1, right? So 3 times 2 and then times 1, right? So all the way down to 1. Now here we have n plus 4 factorial, we have n plus 3 factorial, and we can recognize that n plus 4 factorial has an n plus 3 in it, right? And here, from here onwards, this is just basically n plus 3 factorial. So we can rewrite this n plus 4 factorial as n plus 4 times n plus 3 factorial, because here it's n plus 4, right? The extra n plus 4 that differs from the n plus 3 factorial, and here it counts down from n plus 3 all the way to 1. So this part is n plus 3 factorial, so from n plus 4, and then n plus 3, n plus 2, n plus 1, and so on and so forth. And n plus 3 factorial also does a similar thing, but starting at n plus 3 factorial, also counting down to 1. So that's why we can rewrite like this, and then here it's n plus 3 factorial plus 2n, I'm just copying this, is equal to 7. So here n plus 3 factorial, right, both of them the same, right? So we're going to cross these out, okay, divide both in the top and bottom by n plus 3 factorial, and this is going to leave us with n plus 4 plus 2n equals 7. And then from here we can just see like terms, right? This is a like term and this is a like term. We can add them up. So it's n plus 2n is going to give us 3n, then plus 4. So we got this equals 7, and we're just going to solve for n. So here we can subtract both sides by 4. So 4 minus 4 is 0. 3n is equal to 7 minus 4, which is 3. And then we could divide both the left side and right side by 3. And then this 3 and 3 cancel. So this is just going to leave us with 1. So n is equal to 1. And here we have solved this equation for n. Alright guys, this is the end of my YouTube video. Thank you for watching. If you enjoyed it and it helped, feel free to give it a big thumbs up. And of course, as always, I love to know your thoughts on my YouTube videos, so remember to comment down below. And if you're new to my channel, feel free to hit that subscribe button. And I hope to see you next time for another math video. Bye!